All right, we are back, class 22, multiplying and dividing rational expressions. Let's see what we got going on today. So not too much difference to adding or subtracting rational expressions. We're going to kind of combine that with when we multiply and divide fractions. So going back to kind of middle school math in terms of how to do that with fractions, a little bit of algebra 1 as well, because we'll be dealing with exponents and just adding, subtracting exponents at times. So just make sure if you don't know those things, you give them a quick Google, you turn up to office hours, you go to the tutoring center after school, and you just make sure that you are good on those topics. Let's take a look. So last class, we were doing the lowest common denominator of two polynomials and then adding or subtracting them. All right, let's take a look at multiplying first. So when you have two fractions, let's say you've got a over b times c over d. The way we multiply fractions, the numerators multiply and the denominators multiply. So you get ac over bd. That's it. You're done. We're going to do the exact same thing here with polynomials. However, there is one step before that. I want you to factor the numerators and denominators first, because we're going to look for anything that is an excluded value that we could potentially knock out before we do all of our complicated multiplying and dividing. So for the first one, 3x squared, that's a 3 times an x times another x, all over. X squared plus 2x minus 8, so factors of negative 8 that add up to be negative 2. That would be negative 4 and positive 2. So x minus 4, x plus 2. And this is all multiplied by 2x squared minus 6x minus 20, so that 2 can be factored out of that whole thing. So 2x squared, so that'll be x squared, I'm just going to put that up here, minus 3x minus 10. So factors of negative 10 that add up to be 5, be minus 5 and positive 2. And x squared minus 3x minus 10, that's the exact same thing. So we got x minus 5 and x plus 2. So just looking at this right now, we're going to multiply this together. So the numerators together, denominators together. I'm not going to do excluded values just yet. I want to wait until I've actually done the multiplying, but I'm going to push the factors together. So we're going to end up with 3x, x, 2, x minus 5, x plus 2, all over x minus 4, x plus 2, x minus 5, x plus 2. So then all we do now is cancel out those common items and then write what's left. So we've got 2 times 3 is 6 times x, so 6x squared. And then x times x is x squared. We've got plus 2x minus 4x. So we've got, I guess we're just left with the original denominator, so minus 2x. And then minus 8. So that would be my answer. But the excluded values, I go back up to wholes and asymptotes. So what were the values of the denominator when it was all in factored form that would give me 0? So if x minus 4 is a factor, an excluded value would be when x is equal to 4. Minus 2. We've got positive 5 and minus 2 again. So there's 3 excluded values, 4, negative 2, and 5. So any of those values in the denominator would have resulted in an answer of 0, which would have made the whole thing equal to infinity or undefined. Okay, let's go for another one. So first step, let's get it all factored down. X squared minus 8x, common factor is x. And we're left with x minus 8. All over. 14's already taken out, which is kind of handy. Factors of 15 that add up to be 8, that would be 5 and 3. And multiply by, we've got 7, x plus 5, over x plus 8. Push it all together. So we got x minus 8. We've got, all right, so then push them all together, sorry, x minus 8 times 7 times x plus 5 all over, we got 14 x plus 5, x plus 3, x plus 8. All right, so x minus 8, x plus 8 do not cancel, but the x plus 5s do. And 7 will cancel down with 14. Doesn't really matter much, but it does. Okay, so then we're left with x times x minus 8, so that's x squared minus 8x, all over x plus 3 times x plus 8, so that's x squared, and then times 2 is 2x squared. We've got 3x plus 8 is 11x, so times 2 is 22x. And then 3 times 8 is 24, times 2 is 48. So then we should be able to say, all right, there's our final solution. Factor form would have been fine, really. I don't necessarily need you to multiply it out. And our values of x that are excluded, so the ones that got canceled are definitely in there. So we know excluded values, x is equal to -5, so that would have been a hole in the graph. And then we would have had asymptotes at -3 and -8. So the other values of x that would cause the denominator to be 0. Your turn. So excluded values and products of the two questions, please. So you got question 1 and question 2. Pause the video, come back, and see how you did. All right, let's go. X squared minus 9. So that is actually a difference of 2 squares. Did you recognize it? X squared minus 3 to be squared. So that's going to be x plus 3 times x minus 3. And then that's all over factors of -24 that add to -5. That will be -8 and +3. So x minus 8, x plus 3. So we're going to have something that cancels. And then x minus 8, nothing changes. 2x squared minus 18x. So 2x is common. I guess that would technically be separate factors, 2 and x. And then we're left with an x minus 9. All right, so push it all together. The x plus 3s will cancel. X minus 8s will cancel. So we're left with x minus 3 all over. Looks like nothing canceled on the other side, so we just got 2x squared minus 18x again. Excluded values, we've got +8, -3, 0, and 9. So 0 in here, 9 in here, -3, +8. For number 2. The only one that needs to be factored down more is actually the top right, just the 3 x minus 7. So we got x and x minus 9 times 3 times x minus 9 all over x plus 1. So the x minus 9s are going to cancel out. So we're going to have x times 3 is 3x over x plus 1. Our excluded values, we've got 9 and -1. So 9 being a whole, -1 being an asymptote. So yeah, multiplication, pretty straightforward. Division is going to be a little bit complicated, but not much. So when we're dividing, if you remember from your days of working with fractions, let's go back to that a over b example. A over b divided by c over d. When you're dividing fractions, what actually ends up happening is the divisor fraction, so c over d, ends up flipping and then multiplying. It's called the reciprocal. That's just, if you were to try and do dividing a fraction by dividing by a fraction, you would see that that's what ends up happening. So like if you did something like 6 divided by a third, you'd be asking, well, how many thirds are there in 6? Well, it would be 6 times 3, which is where we get that 18. So anytime you're dividing by a fraction, it's going to invert and multiply. It's called that reciprocal value. So we're going to end up doing the same thing here for our division of polynomials. We still want to go with the factors though before we start. So we got x plus 7 times x plus 7 all over x times x divided by factors of 14 that have to be 9, it's 7 and 2, x plus 7, x plus 2. Let's do that properly. All over factors of negative 2 that have to be 1, that'll be positive 2 and negative 1. All right, so now you are going to flip the divisor fraction and multiply. So we will get x plus 7 times x plus 7. And then if we flip that denominator, we're going to get x plus 2, x minus 1, all over x plus 7, and x plus 2. All right, start canceling. X plus 7s will cancel out, x plus 2s will cancel out, and that's it. So we get x plus 7 times x minus 1 all over x squared. Now the excluded values here is a little bit more complicated. You've got everything you canceled out like normal. Those are wholes. So we've got wholes at minus 2 and minus 7. You've also got for the remaining denominator, so the two x's, so we've got 0. And then you also have to look at the original divisor. So there is an additional one here that we didn't account for already, and that's when x is positive 1. Because imagine now we had done this, you would have said x plus 7 squared divided by x squared divided by, and if x had been equal to 1, this would have been infinity. So it would have been all of this divided by infinity. It's not really possible. You approach 0, but you never actually get there. It's still an undefined value. So that value of 1 would be considered another excluded value. So that's a common mistake people make, is they forget to go back and get that extra one. So they'll get the 3, but they'll forget that extra one. All right, let's try it again. 6x, that's just 6, and x, 3 times x minus 10 divided by, so we can factor out the 9, and that leaves us with x squared minus 3x minus 4. So we would have x minus 4, x plus 1, all over x is common, so x minus 10. Nothing canceling out at the moment, which is totally fine. So then let's just flip and multiply. So it's going to be 6 times x times, we're going now for the denominator on the other side, x again, and x minus 10, all over 3 times x minus 10 times 9 times x minus 4 times x plus 1. So the things that are going to cancel, the x minus 10s will cancel, and 6 will cancel down with 3, and we'll be left with a 2. Okay, so that's it. So we got 2 times x, so 2x squared on top, and then we've got 9 times x minus 4, so it's the exact same value as what we started with up here. So it would just be 9x squared minus 27x minus 36. Excluded values, so we've got positive 10, we've got positive 4, we've got minus 1, and just go check on your original one again, there is an extra x down here, so 0 is also an excluded value. So just be aware of that. You don't want to miss out on that last one. All right, your turn. Let's do this. So 2 questions again. Pause the video, come back, and see how you did. Don't forget to put the excluded values in there as well for your answer. All right, so first one, x plus 11, that's already factored. Over 4x, so you've got 4 times x divided by 2 times x plus 3. And we've got x plus 3, x minus 1. So flip it, multiply, we get x plus 11 and x plus 3, x minus 1. And then we've got 4 times x times 2 times x plus 3. So the x plus 3's will cancel. So if we're thinking of excluded values, we're going to know minus 3 is in there, also 0, and then also positive 1. X plus 11 times x minus 1 all over 2 times 4 is 8 and x. So that would be my quotient. So after it's actually been divided, this is what's left. And you could distribute this to do x squared plus 10x minus 11. I'm okay with factored form for now. So you're good if you want to stop there. For the second one, top part's already good. 20 x squared minus 7x, so that's x times x minus 7. And this one is multiplied, so we actually can go straight across here. You know what? I think that was a typo on my part. Let's make that a division symbol because we're practicing division at the moment. So to make it a division symbol, so let's divide this. 5x squared minus 40x. So we've got 5x times x minus 8 all over x squared minus 15x plus 56. Factors are going to be negative 8 and negative 7. So x minus 8, x minus 7. All right, flip it and multiply. So the divisor is going to flip. 20 times x minus 8 times x minus 7 all over x minus 7, 5x, and x minus 8. And really that 5 and x should be separate, so I'm going to separate those. So we've got x minus 7's cancel, x minus 8's cancel. 20 and 5 will simplify, so we're left with 4 up here. All right, so that means on top we're going to have 4, and on bottom we've got x, so that's it, x squared. So a lot of stuff canceled in this one. My excluded values, we've got 0, 7, 0 again, 8, and just checking the original one, 8 and 7 already accounted for, so we're done. So just 3 excluded values on this one. All right, that brings us to the end of today. How do I identify excluded values when the rational expressions are divided? You factor it first, you invert, so you do the reciprocal of the divisor fraction, then multiply, cancel out any common values, and just check that you've got all the excluded values included. All right, so that brings us to the end of this week's lessons. You've got math tasks to complete, and then you've got your first checkpoint for Unit 4. So that's going to be our first quiz of this term. Make sure you are prepared for it and get it done by Friday at midnight. Talk to you all soon.